Okay, now we're going to look at the power of imaginaries. So what this is talking about is with our I, sometimes you're going to see an I with a little exponent by it. Now there are kind of four categories of these I's with the exponent. The first are I's that are just divisible by 1. I to the power of 1. You can't divide it by 2, 3, or 4. It's a prime number. Those are always just going to be an I. It'll stay that way. When you square I's, or if your number is divided by 2, it becomes -1 because the square root of -1 times the square root of -1 gets rid of the radicals and we're left over with a -1. If we were to multiply that number by 1 more I, so -1 times I get -I. And if I were to multiply that times another I get +1. So you start to see these patterns emerge where every number, as we go up with powers, goes I, -1, -I, 1. I, -1, I, 1, and so forth and so forth. So if you see a problem like this, and it asks you, what would this number be simplified? What you're going to do is figure out what's the biggest number. So I'm going to start with 4. I actually don't know why I'm doing this. I'm going to see if it's divisible by 4. I get here that 80 divided by 4 is 20, which means that I to the 80 can be written as I to the 4 to the 20. So if I simplify I to the 4, I get +1. +1 to the 20 is just 1. Looking at the next one, I to the 21. 21 does not multiply clearly by 4, so that one's not going to work. However, it does divide by 3. So if I simplify that to I to the 3rd and raise it to the 7th, then I get -I to the 7th power. So my answer is going to end up being -I. It's a pattern. Once you figure out what it's divisible by, then you can simplify it and figure out if it's going to be 1 or -1 or I or -I. It's a pattern. That's always going to be what it simplifies down to.